Okay, so let's talk about some C++. I expect some of this stuff's going to be a review. Some of it will probably be new, and we're going to kind of talk about both some kind of review things as well as some stuff that relates to the current course. So really, I kind of want to start with looping in C++, which means basically we need some data to kind of loop over and so forth. So we'll start there. Here I have a C++ project created, default project created in CLion. I'm going to make one little change here. I'm going to come over to my cmakelists.txt, and I'm just going to bump up the version of C++ that we're going to use to C++ 14. Okay, so I'll go ahead and I will save that. Control S. Yes, it needs to be reloaded. That's fine. Okay, and then yes, it's updating, etc. Okay, so let's take a look at a couple of things, right? So let's just do, let's start with something real simple, creating an array. So we create an array in C++ by first specifying the base type, that is the type of thing that we're going to store. So here I'm just going to create a simple array to store some numbers. Okay, so basically it's going to be an int array, so we're going to store whole numbers. I'll call it nums, and of course we use the brackets to show that we're declaring an array, and then I'm going to give it the contents of the array. So 1, 3, 5, 7, 11. So there we go. Okay, so we have a bunch of numbers here. Now, a couple of notes about this syntax right here. This is what's known in C++ 11 as the unified initializer syntax. Okay, it's a new syntax that allows us to initialize really a whole host of different things using the same notation. Originally, it kind of started off. We had this similar notation used for raw arrays in C++. You'd usually do something like that, but yeah, we can now do it this way. All right, so let me go ahead and just make sure that this in fact builds. So we'll go ahead and run that. Right, and of course it doesn't print anything because, well, there's nothing to print. All right, so let's look at just a couple of things here, right? So for instance, suppose we want to print out all of the elements in the array, right? So, you know, one way that you may have learned in your previous classes is the sort of classic C style for loop, right? So we create some index variable, and as long as that is less than, well, however many elements we have here, 1, 2, 3, 4, 5, we have 5 elements, right? And I++, and of course, now we can do our cout of, and we could have something like nums sub I equals that. Okay. So let's go ahead and try to run that. And of course, you'll notice it is actually complaining about cout and endl. Again, depending on the style that you learned and so forth, this may or may not be a surprise to you, right? So we certainly would expect this if we weren't including IOStream, but we are including IOStream. So what's going on there, right? Remember, C++ uses namespaces, so things like cout and endl are in the STL namespace. So we can either do this, that is, refer to cout in the std namespace, and same thing here, std namespace, right, and just verify that, yes, that does in fact work, right? So num sub 0 is 1, num sub 1 is 3, etc. Okay, now, if we didn't want to have to type that every single time, it's really, really common for people to do this at the beginning of their C++ program, right? So once we do that, that means that anything that is in the standard namespace, we can just use directly. So we can do, for instance, this, and again, it runs the same. Okay. So that's all the issue is with there. Again, so hopefully for the most part, that stuff is a review, except for maybe the slight little change here in the unified initializer. Okay, let's look at a couple of other things with this. So we have our for loop. We see that we can access the various elements of our array using indices. We do always start counting off at 0. Okay, now a couple of issues and a couple of problems and things about arrays that that we need to be aware of, right? So arrays in C++ are always a fixed size, right? In this case, the compiler is actually smart enough to figure out what size nums needs to be. It needs to basically be, have 1, 2, 3, 1, 2, 3, 4, 5. It has 5 elements in it, okay? And so the compiler basically sets that up for us. Now, one of the things you should always do as a programmer, especially if you're coming to a language new, you should ask the question, what happens if I break the rules, right? So what happens if I try to go outside the bounds of the array? For instance, what happens if I do this? Num sub 5 is equal to... Okay, so let's print out num sub 5. Let's see what happens there. Okay. Notice, nothing. I mean, we seem to be able to do that, right? Now that's kind of weird. Let's try the other side. Let's go to num sub -1. And again, that seems to be allowed. Okay, let's see if I can push it a little bit further. In fact, let's actually just write another loop here. Int I equals, so let's say 6, while 6 is less than, I don't know, let's say 20, I plus plus, and let's basically do this. So we'll see, see if we can kind of go even further out into memory beyond where nums should allow us, right? And notice, I mean, we got so we did finally die a horrible death. Oop, yes, let's see. So what do we got going on? So yes, yes. Well, 6 is always less than 20, so that's an infinite loop. Let's do that. Okay, there we go. I less than 20. Okay, so notice, that one, again, actually worked, but no, we don't always get 0 in those spots, right? So here we got 6, we got 5, we got this big number. Basically, we're kind of picking up the random contents of memory, okay? So the point, there's a couple of things here, right? Notice, I can seem to go pretty far. Now, let me try another one. Let's say print out num sub 1,000. Okay, so now if I go to num sub 1,000, yeah, num sub 1,000 worked. How about nums sub 10,000? Can I get out to num sub 10,000? Let's see. Ah, there we go. Right. So finally, I got to a point that was basically outside the bounds of memory that the operating system allowed for this program. Okay, so the question of, what happens if you go outside the bounds of the array? Well, in the best situation, your program dies a horrible death, right? Notice I said the best situation, right? Why would that be the best situation? Well, because realistically, we would really want all of these things to generate an error for us, right? But notice that, all of these lines, 11 all the way through 17 here, all of these worked mysteriously. Okay, that's kind of weird. But if we did go far enough out, then we finally actually got a real error. Okay, so this is kind of a nasty little bug that's in C++. But I haven't even fully showed you the full extent of all of this. Let me do this. Okay, so suppose I just create some number here. And I'm going to call this variable before because this variable's declared before the for loop, right? So I'll say, okay, before, and I'm going to give it some value that's not in this range. So let's say before has the value 13. And then I'm going to create another variable called after, and let's say that has the value 100. Okay? So before has the value 13, after has the value 100. Now, let me go ahead and run this again real quick. I'm going to comment out the line that is killing our program, because we know that if we go that far, that's definitely going to cause the program to die. But now if I go back in here and we take a look, one of the things that I want you to see, so here's nums. We kind of keep scrolling through. Take a look at that. Nums 9 is equal to 13. Where did we have 13? We had a 13 here. Now, are those the same 13, or does that just happen to be kind of random stuff, etc.? Let's take a look, right? Also, we do have 100 in there. So, let's see what's going on with this, right? So let me try changing this to something else. Let me try changing this to negative 75. I don't care. And then, and again, since we have that 100 there, let's see if that's not something else. So let's do just 123. So let's kind of see if any of these values end up being changed accordingly. Right, so now when I run this again, and I'm going to scroll back, so notice nums sub 8 is now 123, and nums sub 9 is negative 75. Okay, that's kind of interesting. Okay, now, in case you haven't fully grasped what's going on here, okay, what that probably is telling me is that if I do, instead of just printing out the values of certain things, if I happen to be assigning values, let's say, for instance, I happen to say set, or let's do, I can do it this way. Okay. So I'll double each value. Right, so as I go through, I'm going to double each value from 6 all the way to 20. Okay, so you say, all right, great. So we went from 123 to 246, and we had our negative 75 that was over here. That's negative 150. So what? What's the big deal? Here's what I want you to see. Okay, so notice the only place we've touched before and after are right here where we created those and set their values. Okay, so down here we should see before is negative 75, after is 123. I'll go back in here and take a look. Their values have been changed, right? And their values have been changed because by writing outside the bounds of the array, C++ was happy to just allow us to do that. And it turned out when we went outside the bounds of the array, it turns out that the same area that nums 8 would be at turns out to be roughly where the variable after lives. And similarly, it turns out that where nums 9 would be, that's where the variable before lives. Okay, So that is a very big problem. Now, I know a number of you are also in my ethical hacking class, and this is actually a preview of what we're going to talk about there, something called buffer overflow. And we're going to actually play around with this in that class. A hacker would in fact use this technique to write their own values into the computer's memory so that they can then take control of the actual program. So clearly, this is a really, really big problem. This is an issue that you do need to be concerned with. Okay, so let's talk about a couple of different ways of dealing with these things. Now, one issue has to do with how we are dealing with iterating through the array. Okay, the bottom line is using this variant of the for loop for executing code across all of the elements of an array is inherently error prone. Okay, and what do I mean by that? Well, take a look. We are almost setting ourselves up for failure. Okay, we have so many different ways here to mess up. For instance, suppose I forget the fact, very commonly for beginners, we forget the fact that we have to start counting here. Instead, we start counting at 1, right? And maybe we actually write this instead, right? Or maybe we have the 0 in here and just do that. Okay, so again, we're going outside the bounds of where we should be, right? So once I get to I sub 5, that's outside the bounds of where I should actually be. I shouldn't be at num sub 5 ever, right? Or if I started at 1, then that means I'm actually going to skip the first element, right? Again, oops. Okay, and like we saw before, I could screw up this by what I did here when I was sort of typing, and I actually typed 6 less than 20 as opposed to the I less than 20, right? So I can mess that up in a whole host of ways. You can even screw up your increment, decrement. Remember, because this can be decrementing, this can be all kinds of other things, right? So there's all manner of ways that we can mess that up. Okay, that's not a good thing then, right? So what we do have with C++ 11 is something called the for each loop. Okay, so a for each loop looks like this. So if I know that I definitely want to execute certain code over all of the elements in a collection, I can do something like this. I can say for every, and then I can do some since the type of things that are in there are ints. I'll say, okay, I want to use those. Very frequently, we'll be wanting to change those, so we'll actually do it as a reference. And then I'll just say nums. Right? So if I do that, here's what I can do. Okay, so I'm going to comment this out. I'm actually going to comment out this other stuff just to get this out of the way. Okay, so let's take a look. Right now, if I just do cout n, here's what we get. 1, 3, 5, 7, 11. Right? So this, it can be read as for each, right? For each n that's in nums, do something, right? If I wanted to double them, I could say set n equal to n times 2, right? Or the sort of, slick C shortcut way of doing that, which is n times equals 2. Either one of these things will do the same thing, right? But notice, then we see, oh yes, we have in fact doubled all of those, right? This, much less error prone. Okay, notice we do want to iterate across all of the elements, but we don't have to rely on setting up the exact beginning and ending points. Okay, makes it much easier in terms of dealing with all these things. Okay, so right away, using something like the for each loop in C++, really, really handy. Now, another thing Because, this kind of pattern of, do something to all of the elements in an array is incredibly common. Right. So, for instance, maybe I have something like a function here where where I'm basically just going to say, okay, I want to square something, or well, we've already done squaring. Let's say cube. And we'll pass an int by reference. I'll give it a different name just so that that way it's not too confusing. Right, set k equal to k times 2. Okay, great. Right, so one way of cubing all the numbers is that what I could do is something like the following. So again, I'll just comment this out to get that out of the way. But what we'll do is we'll say, okay, for, again, every one of those. And we could say we want to go ahead and cube n. And then, just again, I'm going to do this. And we'll say output n. And this time, actually, what I'm going to do is just we'll put them all on one line, so it'll make it a little easier to read this stuff. Okay, so cube all the elements, and then print all of them out. Okay, cool. Let's take a look at that. And yeah, so what did we have? What did we start with here? Oh, well. For one, that's not cubing, that's doubling. That's why we have a 2 there. I was just wondering about that. Yeah, cube would be this. There we go. Helps if you kind of think about the code you're going to write. All right, yes, k is equal to k times k times k. That's a really unfortunate choice of variable name, especially in that. Let me show you a quick little feature here of CLion, right? So if you decide you want your variable named something different, notice we can do a rename, and I'm going to name it L, right? So I do that, and notice it changed all of the appropriate occurrences, right? So L, right? That's a little bit better. Doesn't have the pejorative notion that the other one does, right? So there we go. All of those things are in fact cubed. Okay. A couple of other things that we can do here, right? So one, technically speaking, I don't really need the reference here because all I'm doing is printing those out, right? Notice that doesn't change the result. Here, however, if I take off the reference, you'll notice, oh yeah, that actually does change the result. Why? Because here, basically, n is being used by value, right? So deal with each element in the nums array by value, like by value when we call parameters. In other words, we have a separate copy versus here doing them by reference. And so any changes that we make actually make a change in the values in the numbers. Okay, so that's the first part. Now, a couple of stuff about this as well, right? You might look at this and you go, oh, okay, let's see. So I want to go through all the numbers and, okay, what was that's right. Those were ints, right? So, but realistically, I mean, the thing is that, C++ should be able to kind of figure this out, right? I mean, the fact of the matter is that, well, nums only stores integers, right? It doesn't store anything else. We've told it up here exactly what it stores. So again, in C++ 11, what they've introduced is the auto keyword. And the auto keyword basically tells C++, hey, you figure out the type here. Right now, it can't always do this, but certainly in cases like these, you'll notice it's perfectly fine. It says, "Oh yeah, fine. Yeah, you know what? I got you covered. I know that this is an integer right up here. Yeah, it figures out that it's an int. I do still pass along the fact that I want to deal with it as a reference, and we're good to go." Okay, kind of cool stuff. But the real reason that I was introducing this was to show another thing that we can use in C++ for doing kind of the same thing. Okay, so I'm going to go back over to our class website. And you'll notice I actually have these two C++ reference pages, right? So if I just go to each of these, we'll see the, yes, that's right. Okay, let me click on each one of those. Yep. Really? Oh, brother, oh, that's right, because, all right, I will fix that. So that one apparently doesn't respond to HTTPS. Does this one respond to HTTPS? Looking like not. All right, that's fine. I'll also fix that one. There we go. So these tell us about all of the different header files that are available to us for C++. So I'm going to go here up. I'm going to go up here in this one to Other. And there's this header file called algorithm. Same thing over here. So if I come over here, you'll see there's the algorithms library. And what the algorithms library basically is a collection of generic algorithms, right? So notice there's a for each function, there's a counting function, various find functions, right? Ways of copying sequences and so forth, right? So a lot of very common operations that we tend to employ are already written for us in C++, right? And again, depending on your previous C++ class, not a lot of introductory C++ classes cover these. I don't know why, because they're incredibly valuable for both beginners and novices, or beginners and experts alike. But nevertheless, there it is. Okay, so for instance, for each, apply a function to a range, right? So you take a look now. One of the issues is, when you first look at this, you look at the header for the prototype for the functions, and it just looks like a mess. You say, what am I doing here? How am I supposed to deal with this? What is this? Right? We have templates going on, right? And this input iterator thing, which is just a template type, and then we have functions, and what exactly is happening? Okay, so this idea of an iterator is a way of accessing the various elements of a collection in C++. Okay, that's all it is. And function, like the name, is literally a function. Okay, so they actually kind of show you what the code basically looks like. And the thing that I want to sort of point out is they're really doing a couple of things here. One is they're using the star operator, which, if you don't recall, that's when we're dealing with pointers and for dereferencing a value. Plus, we're incrementing it, right? So if you did pointer arithmetic, you've seen things like dereferencing a pointer and dealing with incrementing the pointer as well, right? Now again, that's fine. Let me just get rid of that. Okay. Now the thing is, again, pointers are one of those topics that beginners, they have some issues with and all that. So, if you're hearing this and you're going, oh, great, these iterator things are like pointers, and I never really understood in pointers, it's fine, because honestly, you don't really need to know that much. Here's basically what you need to know. Let me show you how to actually use this. Okay, so we see for each, we need to be able to find we need to be able to identify the first element in the sequence, and this last is basically one past the last element. Okay, C++11 has a really easy way of doing this. So I can rewrite this whole thing like this. So I can say for each, and let me go ahead and hit Alt-Enter, and it says, which one do I want to use, and I think I want, let me see. No, that's really not it. I did not pick up. There we go. Algorithm. Okay. So there's my for each, and so I need to be able to find the beginning point of nums. Well, there's this great function in C++11 called begin that I can actually pass it an array, and it will magically figure out the beginning of the array. Similarly, I can call the end function, and that will tell me one past the end of the array as well. So there I have the beginning of my array, the end of my array, and now I just need a function. So the function, which we had created here, is cube, and we're good to go. So in other words, I can actually have this replaced with that, right? And just reading the code almost tells us exactly what we're going to do. For each in the sequence from the beginning of nums to the end of nums, cube them. Let's try it out. Notice there's the same result, right? So our code becomes much easier to understand, right? We have the exact intent of what it is that we're trying to do expressed by using these higher level functions. I could do the same thing here, right? Now, here's the point that I want to make. Here I happen to have created this cube function. Now, if this is the only place that I was using cubing, it seems kind of a waste, because what ends up happening is I've created this separate function here that what C++ programmers would say, it pollutes the namespace, right? This function sitting out there at the very least, the whole scope of this file for anybody to use. And it seems like kind of a lot of work to have done for just this simple operation. Okay, well, again, C++ 11 has a little trick up its sleeve to make that easier. And I'm actually going to show you first, well, actually, you know what, since we were talking about cube, let's start there, and then I'll show you how to convert this for loop the same way. Okay, so another way of writing this is basically, let me do it this way. Okay, so I'll do Control D, which duplicates the line. Very, very handy. And then, so I'm not going to use the named cube function. Okay, what I'm going to do is I'm going to use a function that doesn't have a name. Basically, an anonymous function, or what is also referred to as a lambda, because the idea for this came from the lambda calculus. Okay, so we start off with that. We say the type of things that we're going to take, ints by reference, and then we can have our brackets. And then I can simply say return, or rather, n is equal to n times n times n, like so. Okay, so there's my function. I am now, right, so literally this whole thing here is the function. The function doesn't have a name, and we've said that it's going to take one value as a parameter, an integer by reference, and we're simply going to do that. And again, I'll actually, what I'll do is I'm just going to refactor this here to make it very much like our last one. So I'll call this L, right? So just like we had before. And again, let me prove that that this does in fact work. Right? So here we have our anonymous function that that allows us to do the same thing that we were doing with cube. Right? So I would not have to have declared cube for doing that. I can now do the exact same thing down here, right? So just as we're dealing with outputting the variable, I can replace this with something like that. Let me move this over to here. Comment those out. Okay. So once again, I don't need to for output. I don't need to actually use those by reference, but I could. I mean, there's no reason why not. And I can even use the auto keyword here too. So, and again, we'll just say that. Right, so we do that. There's our outputting the end L, and let me go ahead and run that. Let's see. Oh yes, right, because I named it L there. So let me do the same thing here. Okay, and there it is. So now we've changed our use of these over to using for each with anonymous functions. Now, which one do you have to use? Which one should you use, etc.? It's up to you. Honestly, you know, I would strongly encourage you, if you do not need to have the index, don't use this version. At the very least, you should be using something like the for loop with the new for each syntax that's built into C++11. Right? I encourage you also to start thinking about using things like the for each function that's part of the algorithms header, and start thinking in terms of lambdas and so forth. Right? We can actually even sort of take this further and so forth, but I'm not gonna quite do that just yet. Okay, so those are some ideas for using some of the stuff, some of the standard template library algorithms in terms of making dealing with arrays a little bit easier. Okay. Now, I don't want this particular video to become too overly long, but there are other things that I'm going to talk about. We're going to talk about sort of an alternative to the array that also deals with some of the other issues, but I'm going to do that in a separate video. And if you have questions, just shoot them to us over on Piazza, and either I or the TAs will be happy to help you.